First of all, I should give you a quick grammar about the creation of unknown material. When two conductors are connected to the electricity, the gap between them will be filled with that unknown material. The formation of precipitated mass of unknown material must be come from somewhere, isn't it? It was obvious for me after many experiments that one part of the special conductor must always lose its mass. Even we change the polarity of DC battery, positive and negative pole, it will not change the direction of chemical process. That means we can use AC voltage type of electricity with this kind of system. The small piece of unknown material has only been eliminated alone without affecting on the near metallic conductor. As I saw from the previous experiments, the new chemical compound has not been oxidized by surrounded air, and the bright light was proof of that. The important thing about that new material is that it wasn't sublimated like carbon or deteriorated its mass with time. In fact, the mass of it can be increased by specific method. I have four scientific hypotheses that I think it will explain what happened in that strange experiment. 1. Oxygen has been act as inert gas around the unknown material, in contrast with the tungsten in the incandescent lamp. It seems that the required force to separate two oxygen atoms or molecule is not enough due to the strong chemical bond of that new chemical compound, which it has more electromagnetic force rather than the covalent bond of oxygen molecule, electromagnetic affinity. 2. There is a gas shield created around the unknown material which prevents air from beginning the oxidation process. Maybe that explains the gas that I have smelled before. 3. The unknown material are acting like semiconductor material which has an electrical conductivity value falling between that of metal like copper, gold, and an insulator such as glass. The resistance decreases as the temperature increases, which is behavior opposite to that of metal. We have proved that unknown material has the property of conduction and insulation in video part D. I think that chemical compound may contain at least carbon atoms which have 4 free electrons in the covalent bond. These free electrons are restricted to move by the another atom of chemical compound but with specific potential energy above threshold voltage. It will happen a breakdown between a carbon and the other atom which lead to make the motion of free electron is possible to pass electricity. In stable status, the cold environment, the covalent bond of chemical compound will prevail and insulation property of compound will be returned back. 4. I will assume that there are nano holes inside the unknown material configuration. These holes let a specific gas like oxygen, nitrogen, or carbon dioxide or water vapor to infiltrate inside it. When we apply the small voltage on unknown material, that kind of gas will be ionized as a result of microgaps. As we know, air is ionized as 3000 volts per millimeter, so in microscale the ionization of air will be 3 volts per micrometer. But since we don't see the characteristics color of ionized air, which is bluish or purple color, so I will guess it is not air. It must be another type of gas, and maybe it was that gas I have smelled before. Actually, I have another interpretation, but I am sure that scientific communities will not accept it unless we measure it precisely. I was thinking that the visible light of unknown material has been illuminated in low temperature, which is contradicted with the physical experimental results. As I said before, I was able to measure the temperature of metallic plate by using digital laser thermometer. It shows me a temperature of 140 Celsius degree and 209 Celsius degree when I use 3.7 and 9.7 volt of phone chargers, respectively. Definitely, it is an absurd idea and not consistent with Max Planck's experiment of radiation spectrum of black body. Also, I said previously, there are many factors determine the temperature of metallic part, such as the exposed area, motion of air, and rate of energy. Now, let us see what is sector of industry which can be utilized this strange phenomenon. Besides using the strange phenomenon in lighting application, there are many other applications, but let us ask ourselves one question. Why we don't why we do why we don't use electricity for obtaining a high temperature? Because metallic conductors will be oxidized in high temperature, which lead either to convert metallic material into insulator or deteriorated corrosion. So our unique feature of that unknown material is the ability of preventing the oxidation process. There are many industries. There are many industries will benefit from this strange phenomenon, such as 1. Ignition industry. In market there are some kind of electronic ignition device which use it for firing kitchen cooker. This device has ability to recharge it easily, and the price of it is approximately about $5. Some cheap ignition systems are using either gas, fuel, or piezoelectric effect, and it is good more than using traditional matches. The principle of electronic gun device is quite simple and it's based on gas ionization. The low voltage of battery 9 volt will transform it into very high volt up to 15 kilovolt. In this value of voltage, air may be ionized in a gap of 1 centimeter. Recall that 3000 volt per millimeter is the air ionization and give very high temperature, more than 2000 Celsius degree. Now the strange phenomenon, if we accept it, it is not a kind of ionization gas. It's based on heating a material which we remember that it does not oxidize. So we can reach a high temperature easily. We don't need a high voltage equipment, no transformers. Simple, isn't it? Then the price of product for customer will be cheaper than electronic arc igniter in the market. 2. Welding industry. There are two types of welding, cold and hot welding. The cold welding, contact welding, are always using solid state process in which joining takes place without fusion or heating at the interface of two parties to be weld. Unlike in the fusion welding process, no liquid or molten phase is present in the joint. The hot welding is a thermal welding technique which uses a fusion energy to marry two or more same material together. They always use it in the electronic or electrical boards to connect small electronic units such as a resistor and a capacitor, which always has a temperature less than 500 Celsius degree. For higher temperature we use arc welding type for bonding many materials such as copper, iron and steel. Now by using the unknown material it will help us to weld without worrying about oxidation process which it always occur in a high temperature environment. Three. Heating industry. Electrical resistance heating is one of the most efficient forms of thermal processing for industrial sectors. It uses a thermodynamically stable resistors to convert electricity into heat or high performance insulation materials to distribute temperatures uniformly throughout the heating chamber. The most efficient high temperature heating elements are subsequently composed of multiple materials. The precious and rare metals are the tungsten, and engineered ceramics like silicon carbide are broadly used to fabricate high temperature heating elements of varied geometries to suit a range of furnace architectures. Most heating elements use nichrome 80 per 20, 80 for nickel and 20 for chromium, wire, ribbon or stripe. Nichrome 80 per 20 is an ideal material because it has relatively resistance and forms an adherent layer of chromium oxide which, when it is heated for the first time, material beneath this layer will not oxidize, preventing the wire from breaking or burning out. The credit of creating nichrome material was to American young engineer named as Albert Marsh, who designed an alloy of nickel and chromium which come to be known as nichrome in 1905. Great properties, isn't it? Especially the matter of preventing the oxidation for the inner core of materials. So why we don't use nichrome 80 per 20 instead of tungsten? The problem was on the melting point of nichrome. Nichrome has a melting point about 1400 Celsius degree, and the melting point of tungsten is 3422 Celsius degree. For typical incandescent, the tungsten filament operates at approximately 2227 Celsius degree or 2500 Kelvin. That's the scientific reason of why we don't use nichrome 80 per 20 for high temperature applications. Resistance wire are used today extensively in common heating devices such as a toaster, a hair dryer, furnaces for industrial heating, floor heating, roof heating, pathway heating to melt snow. The most common classes of material used include canthal wires, cupronickel alloys for low temperature heating. There are also many materials for heating process such as etched foil, molybdenum disiliciate, PTC ceramic elements. Every materials of heating elements has its unique physical and chemical characteristics, cost of production and validity of products. I don't know anything about the properties of unknown material except that it has ability to prevent oxidation and can give us a bright color which indicates a high temperature, without mentioning the duplicity between insulating and conducting behavior. Finding the melting point of this unknown material will let us to know if it is valuable material or not. Transportation industry. Making fly car as a commercial product was a dream for everybody after we succeed to build a planes and after we loved scientific fiction movies and novels. Engineers and scientists are always thinking about it, but they knew how hard to do it efficiently. Recently, few companies in the world are in the prototype phase to estimate and evaluate the efficiency and effectiveness of their own fly car product. All products are based on the principle of lifting either by wings, like plane, or fan, helicopters. Let us talking about another concept which is related to high temperature environment. As we know, increasing the temperature of gas will lead to increase either pressure isochloric process, density isobaric process, or both adiabatic process of them according to the ideal gas law. Now let us assume there are two situations only, isobaric and isochloric. Suppose the temperature of air has been increased from 27 Celsius to 2127 Celsius. So, in isochloric process, the pressure of air will increase from 1 bar to 2 to 8 bar. If we want to utilize from this high measure of air, we can apply the concept of rocket engine. How? Rocket launch are based on the expansion of pressurized hot gas and the third law of Newton by using fascinating device called nozzle. That's what we will do exactly with car. As you see in this photo, the cold air will be suffered to high temperature at constant volume. Then this hot and pressurized air will pass through bending pipe to nozzle. After that, everything will go similar to the rocket and it will fly into space. By the way, the average mass of rocket may be 500 tons, so I think fly car must be made by enforced plastic materials rather than expensive and heavy metal. Actually, I don't like the idea of being fly to high altitude because if happen anything wrong for any reason, the car will fall and not only the passengers will be in danger if it fall in populated zone. Lifting car up to 20 cm may be good choice in the beginning of this prototype for testing commercially. Yeah, I know that simple design of car will not work for many reasons, such as 1. How you can maintain the direction of air without being reversed. 2. Does the unknown material can withstand the high pressure? 3. Is it efficient and economical to use nozzle, which means the air speed will be supersonic? Anyways, finding answer for those vital questions will let us decide if the fly car based on isocar is possible or not. Thrust issue is simple. We can use the same concept of nozzle or using an air compressor. Buoyancy phenomenon of things on water or air are based on the difference of density. Balloons are flying in high altitude due to the hot gas inside the balloon. Ships are able to float on sea rather than needle because the air holes inside the ship makes the total density of ship steel plus air less than density of water. Archimedes' principle stated that the buoyancy force in water as shown in this law. The general law of Archimedes' principle is by adding the density of air to our equation. But because the density of air is very small than density of water, so we are neglected from our calculation always. If we apply an isobaric process to our previous example to lift car by buoyancy phenomenon, we will notice that density of air will decrease from 1.2 kg per meter cubic to 0.15 kg per meter cubic. If we have a displaced volume of equal to 1 meter cubic, so the buoyancy force of car will be 10.3 Newton. So this external buoyancy force should be equal to the gravity force, and by cancelling the gravity acceleration we will notice that the equivalent mass will be equal to the difference of density multiplied by displaced volume. By simple calculation we will see that 1 meter cubic can lift mass of 1.05 kg. That's the reason why we use very large size of balloon to lift a small mass or few numbers of passengers. You notice that isobaric process is not interested application for lifting objects. If we have ability to create air by density of 100 kg per meter cubic in large pipe, similar to the Elon Musk's Hyperloop, so the new density of air after heating will be 12.5 kg per meter cubic. Now this imagination pipe will let us to lift a mass of object equal to 87.5 kg for 1 meter cubic of displaced volume. Huge number, isn't it? But this will happen if we are capable of making that imagination pressurized pipe.